All right, so now I found T top is 3.2 seconds. Now, if I want to know the Y height, or no, let's first find the total time. What is the total time? It's going to be twice that, 2 times T top, which is going to be 6.4 seconds. That's the total amount of time that it's in the air. It's just going back to our free fall problems that we had last chapter. The time up is equal to the time down. All right, so now that we find the total time, we want to find Y. And we go back to our kinematics equations. The only tricky part here is using the right time. What time do we use here? The total time or the top time to find the maximum Y height? The what now? The top. Right? I want to use the T top here. Because at that time, T top, that's when it's at its maximum Y height. And so I'd say 32 times 3.2 minus half of 10 is 5. So I put in A as negative 10 here. Half of that is 5 times 3.2 squared. Get 102 minus 51. I get 51 meters. That might be a little high, but he goes pretty high up above that road. So that's the maximum Y height. So if we go back here, this is equal to 51 meters. Now I also want to find X. Find X. I say X is equal to V naught X times T. You say, well, we haven't seen that equation, but we really have. This is just a shortened version of this equation, but since AX is equal to 0, this whole thing goes away. So we're not introducing any new equations in this chapter. It won't be until next chapter that we'll see something new. We're still using those two kinematics equations. We're just applying them in different situations. And so here, if I find my X, that's going to be 32 meters per second. And what time do I use here? Do I use the T top or do I use the T total here? Use the total time. Because at that T total, that's when he's at the end of his trajectory. That's when you have this position at T equals 6.4 seconds. And so that's times 6.4 seconds, 32. That's 204 meters. We'll just say 200 meters. 200 meters. So that's our X range. Our Y range is 51. I think this is a little long, like 200 meters. That's pretty far. So what assumption did we make that was incorrect for this, you think? The angle. 45 degrees, man. That is steep. That is a steep, steep incline. Any of y'all ever cycle? No cyclists? Anyway, 45 degree, you ain't climbing that. And it might have been close to 45, but it's probably more like 30 degrees. All right. Here